right, cool. Wow, I'm so excited, guys, to be here, and I'm listening to most of you talking about RxJava and stuff. First of all, I want to start by saying that I divided my talk into three different main parts. The first one is gonna cover why RxJava, because I've seen this scenario play out like thousands of times. Like people usually use it but in the end they don't know why, because it's trendy, because everyone is using it, because there is a big community around it. So these kind of questions we will try to cover in the first part. Then we will see some core components of RxJava and why they are very important. I'm not gonna cover the entire API because that's we are gonna need like a day. And the third part, I will try to expose an example. It's based on a couple of articles I've written in my blog, which is there. It's about clean architecture and how to integrate in your architecture RxJava. So let me first introduce a little bit myself. My name is Fernando Cejas. This is my Twitter account. I try to be active at it. As many of you, I'm an Android engineer working at SoundCloud. I'm not gonna dive deep into this because you might be familiar with the company and what we are doing. So just to get started, I usually like to start by putting like some concepts, what the dictionary says about, what I'll be talking about. So in this case, what is reactive? What does that mean in the end? So if you look into the dictionary or Wikipedia, it's like something that is responsible to a stimulus. It's as simple as that. So based on that, I want to say that we are very used to like use imperative programming, and that brings me to ask a question. Who is familiar here with RxJava? All these hands raised. Are you guys using it for in production? Was good to know then. And the rest, have you guys have touched it or have played around or have no idea about it? A little bit. All right, cool. So yeah, I will try to cover some main concepts as well. So the first one, of course, the most important one is what is RxJava? Um, RxJava came out uh, from reactive extensions, which is something that was created by Microsoft, specifically by Eric Myers. And there's like many implementations. There's like Rx Scala, Rx Kotlin. There's many implementations. So it's basically as you see here, and its concept comes from the documentation. It's a library for composing asynchronous and event-based programs by using observable sequences. That might sound a little like awkward or like difficult to understand in the beginning, right? But let me put it this way. When we are programming, when we are developing with objects, the regular way or the most extended way to develop is by using imperative programming. So to be a little bit more specific, let's put a simple sample when we are looping through a list of elements. So in imperative programming, when we do a for each in a list of things, that internally works with an iterator. So we are just pulling data, right? We are telling the iterator, give me the next item. So what is different, on the other hand, with reactive programming, um, we are have like a more. Sorry, to get back to imperative programming, it's a more pulling, approach, right? We are pulling, we are asking for an element. So on the other hand, reactive programming is more a push model, because you have like something that is doing some computation, something, and then on the other side you have someone who is listening to that computation, and when that job is done, it's gonna send a push notification to the listener. Just keep that in mind, the main difference. So this big difference raises the question: should we go reactive, or why we should go reactive? Because we can solve problems. We have been solving it before RxJava came out, but why we should go reactive? Again, um, I see many people, and I usually like to ask this question when they tell me, "Yeah, look, Fernando, we have been using RxJava for a month, uh, and my first question is why?" And most of them don't actually know why, because usually people tend to, "All right, yeah, but Square is using it, and or retrofit now comes with support for RxJava observables and singles, and because it's cool, I feel cooler, like I'm cool if I'm using RxJava." But that's not true. I'm not saying that, we're at SoundCloud, we use it all over the place in our code base, but the reason is because it's solving some problems for us. It's not because we bet on it like back in the days when it came out, and we are pretty confident and comfortable with that. So the main problems that RxJava solves for us has to do with concurrency. We know that concurrency is pretty hard, especially when we have like complex solutions, and when we need to sync threads, when we need to synchronize many jobs in parallel. So Java offers a series of solutions to this problem, uh, which are not very good for that, for it. And first, we have Java futures. Don't get confused with Java 8 futures. I'm just talking about Java 7 because unfortunately now, and I hope that's gonna change, in the next months. But we are stuck to Java 7, and so we have to deal with that. And so Java futures is a way to solve the asynchronous problems we can find, especially when we have to sync in between like many threads. In our case at SoundCloud, we need to be very asynchronous. We have players, we have tracks, we have playlist, and when our player starts playing a play queue, and it's gonna start like a series of threads, and we'll get the first chunk of MP3s to your playlist. So you're more responsive when you're swiping between tracks. So to give a little example here, this is what a have a feature look like. This is basically a feature is it's a definition of a feature of some type T. In this case, is in a string. I don't want you to understand completely this example. I just wanted to point out what is going on, especially in this line. But basically, we have a pool of threads here. We are creating two jobs that are gonna return a string. And then what happens here? When we want to print both jobs that, in theory, they started in parallel. So this guy here, F1, is gonna block. So even though this one is done, this guy is gonna wait until this is done. So what brings us to the fact that we cannot compose data. We cannot say, all right, just start them and compose them together. We need a lot of code, and it generates a lot of verbosity, like here. But because this is a simple example, but let's go to like a more complex one. We started doing like something like this back in the days when we started developing our app without RxJava. So this is a lot of boilerplate code, and it's not necessary. And again, you see like a lot of problems here, but again, it's about like showing you what a complex solution looks like without RxJava. There is another example that you can dive, later, but this is not friendly, right? And we as engineers, we care about code readability and simplicity, right? We need to code thinking about that, the guy we have next to us is a serial killer, right? I mean, if we show them this, he's gonna like kill us, basically. So again, there's other solutions actually to deal with asynchronous stuff, which are callbacks. Callbacks is the most common way to deal with a thread that is executing, in another executing some job, and then at some point when it's done, when it performed its job, it's gonna send us a callback. We are gonna get a callback, and we can do whatever we want with it. So what happens with this? Callbacks are pretty simple to use. It's the observer pattern, but the problem comes when you have more than one level of synchronicity. So as you can see here, so we are like executing something, we receive a callback, then we receive another callback, and then which nests another callback, and then we can do whatever we want. And this is like really hard to debug. It's really hard to debug. You start like getting lost, on your code base and so forth. So all these problems can be solved in a very simple way. And I would like you to give a warm welcome to our RxJava components, the main ones. I'm gonna be walking you guys through all these ones components, which are the foundation of RxJava. What is an observable subscribers, what are subscriptions, schedulers, and operators, and we'll try to see it afterwards in an example, within an example. So observables. This is the core component, I would say, and it's the guy who does the job. It's basically it's hard to explain because this comes from a functional programming concept, which is called a monad. Do you know what a monad is? Have you heard of that term? All right, so I guess when I mention this concept, it's really hard to understand because there's like tons of articles out there trying to explain what a monad is, and no one actually accomplishes successfully. And so I will give you like a raw definition of what a monad is. This is coming from a pure functional programming approach, and you have to think about a monad that is like a bubble that encapsulates a computation. That's what an observable is. It's like a bubble which encapsulates some kind of computation, and when it starts doing its job, it's gonna send notifications to someone who subscribes to that. That's its a monad. It has two main properties, which is the first one is a flat map, and the second one is a map that don't please yet. We're gonna see later what they are, those components. What is a flat map and what's a map? But yeah, think about that. That's what an observable is, something that performs a job, and it's gonna send a notification to someone which subscribes to it. This might sound like an observer pattern. So what the hell was talking about? Because I told you guys that callbacks are doesn't solve like complex synchronous problems. But there's a main difference. So we have an observable performing one task, and then someone subscribes to it because we are using a reactive approach, right? We said that the observable is gonna at some point push items or to someone who is listening to it. So the main difference between an observer pattern and an observable is that when an observable finishes its job, it's going to emit a signal to the subscriber saying, all right, I'm done. So you can do whatever you want there. Or if there is an error, it's going to send another signal saying, all right, something happened which is not okay, so just trade this error or do something with it. This is a more graphical way of explaining what an observable is. Here we have an observable, some kind of computation, which is emitting weather conditions to some subscribers. This is starting emitting, it's hitting an API and started emitting conditions, weather conditions. Then we have another observable, which is emitting moods. So what is cool about this is that we can like merge these two streams of data, because this is something that I want you to keep in mind. What Everything in RxJava is in a stream of data. The data flows, from observables to subscribers. So this is what happened here. And then in the middle, we can compose, we can merge, we can do many things with what we call operators, and that's coming later. So this is very important, especially when we are talking about RxJava and reactive programming. When we mention, the data flows, those are streams of data. So get familiar with that concept. Then we have our subscribers. As we said, the subscriber is who is gonna listen to an observable performing its job. It's gonna receive a push notification from an observable, and it's gonna process the data. Again, not an observer pattern. I definitely want to highlight this because people tend to confuse, both concepts. And there's another interesting point here, which is that observables often won't start emitting items until someone subscribes to them. So this is very important because we can, encapsulate a computation and just leave it there, and it's not going to start until someone subscribes to that observable, to that computation. Well, this is not 100% true, and I'm lying a little bit here because we have the concept of hot observables and cold observables. There's a hot observable is actually an observable it's always emitting items, right? And a cold observable is what I'm saying here. I didn't want to dig into these two concepts because I've never seen like a use case for a hot observable on Android yet. But if someone has something and has used one of these approaches, please raise your hands and give input. When say it again? Hmm. All right, that could be valid use case. We are not using RxJava at the UI level, and then I will explain why. So, yeah. Anyway, good point. Thanks. Yes. Again, this one, and this is what a subscriber looks like. This is a piece of code of a subscriber. I'm just extending Rx subscriber, and then I receive these three callbacks I mentioned earlier. On complete when the job is done, on error if there's something which was wrong, or on next, when I receive the emitted items by the observable. Another interesting point is subscriptions. These are very important, especially on the Android world. And every time we link a subscriber to an observable, we are creating a subscription. Why this is important? Because we must not forget to unsubscribe from our observables, especially on Android. Otherwise, we will leak in memory. So, for example, when we have an activity and we, for some reason, we are like doing some computation and we are creating a subscription between an observable and an observer or subscriber, and we forget to unsubscribe when we are rotating the screen, that activity is going to contain a reference, and there's going to be a reference there, so that's not going to be garbage collected, and we are going to leak. We're going to be creating leaks. So that's something to keep in mind when dealing with RxJava. Schedulers. This is the approach that RxJava offers to us in order to add asynchronous stuff. So we will specify observables in a very easy way to execute their jobs in a separate thread. So then we will see in an example how that works. We have some built-in schedulers. Here, schedulers.io. This comes from these guys come from the library, and you can use this one, for example, for input-output operations or for some kind of computation. I don't actually know the internal implementation of this, but it's open source, so you can, if you're curious about how they work or what's the main difference in terms of code, you can dig into them. And there's another option, which is you can create your own schedulers from some pool of threads, and this is the approach we are taking at SoundCloud. And operators. Operator, this is the coolest feature of RxJava because it lets us compose different observables, different streams of data. And the cool thing about them is like when we have an observable and an observer or subscriber, there's in the middle, it doesn't matter the amount of operators we apply. You know, our client, which is a subscriber, I mean, if there's whatever data composition is in the middle, we don't have to change our subscriber, of course, unless if we change the contract, you know, between our observable and our subscriber. Um, you can write your own custom operators, but I've never found, you know, a use case where you have to do it. I mean, I think RxJava comes with a lot of them, and you can solve any problem with them. So let's start a little journey on on a few of them, so you get familiar with the concept. So here is what we call the Marvel diagram. So this is a stream of data, an observable emitting items. So we are applying an operator to those items. In this case, map. So what we are doing here is, for every single item emitted by this observable, we are going to apply a function which is going to transform these emitted items into another type. So that's the cool thing about RxJava. We don't have to use like mappers, and we don't need a lot of verbosity, and everything is there. It's really easy to maintain once you get up to speed, and we get back to it later. Flat map is the same as map, but in the end, it's gonna apply a function to every single emitted item, but it's gonna flatten all of items into an observable, so you can keep on composing more and more observables and keep on the chain. Concat map is the same as flat map, and the main difference is, like, I wrote an article about this because I had an issue where I wanted to keep the order of the emitted items, and with flat maps the main difference between them is that flat map doesn't keep the order of the emitted items, so keep that in mind. I wrote an article, and I put some sample code. This is an app which is on my GitHub account, which I used to play around RxJava. And filter, we can filter items. I don't know, we have an observable emitting items, and we apply a predicate because we want to filter them, and if the condition is accomplished, then we receive in our client or the emitted items. Otherwise, they are discarded. We can take a certain amount of items. This is a very important operator, and I found 3 use cases for this one. The first one is like this is like for generating a side effect. Like, for example, when you get an observable emitting items, for each emitted item you can do something, after that. Let me graphic that into an example. For example, and one of the cool things about it is, like, we're using it to cache data. So, for example, we hit an API, we get a list of users or tracks, and when we receive that list of users, we are going to apply this operator, and we are going to execute something, which is to cache those items. And another use case for this would be for logging. You can, when you receive an item, you can log it somewhere. Or now, what I'm doing, now at SoundCloud, I'm working on the search part of the app. And what I'm doing on Next, when I receive my search result after performing a search query, I just track all the results that I received. So this is a very important operator. So we can manipulate or handle errors as well. Remember that an observable is going to emit a signal if an error occurs. There's some built-in operators. I'm not gonna explain them in detail because the documentation does it for me. So, but these are the most common ones, and then of course you can have your own implementation for trading errors. Some key ideas before jumping to the next section, which is more code, more sample related. Just to like sum it up, I think that observables and subscribers can do anything. We found like a lot of problems when we were using imperative problem, and once we jump into RxJava, we could solve all those problems in a very easy way. Of course, there are no silver bullets, and we as engineers know that very well, right? Um, Again, the observables and subscribers are independent of the data transformation that happens in between them. And of course, operators let you manipulate data in any way you want. But, and the bad, however, there are some pitfalls and downsides. Of course, it is not easy get up to speed, especially when we have like someone new joining our team. It takes like a couple of months or 3 months in order to get up to speed, because the learning curve is not easy. But trust me, once you get used to it, you don't see another way. It is like there is like this light at the end of the tunnel once you become like a legendary RxJava ninja or whatever, and it's really nice. And there's in the first version of RxJava, there was this concern about all these anonymous classes that are generated under the hood. So there were some problems, especially with older devices, which would run out of memory because of all the complexity around RxJava and data composition and so forth. But we haven't seen that anymore. Once we, yeah, I don't remember, but API level 14 came out. So there's another thing which is very verbose, especially functions. When you're applying functions on your data composition, you will see that, yeah, I mean, we are missing a little bit lambdas. You can use retro lambda, and we had some kind of discussion. It's a curious thing in our team, but we decided not to use it. First, because we consider it was like some kind of a hack, and then it didn't solve any specific problem to us. It was more syntactic sugar. But well, hopefully with a new Android release, we are gonna have support for lambdas. So let's jump into like some example here, some code sample. I just wanna ask you guys a question about how many of you are familiar with the concept of clean architecture? Have you heard of it? Yeah. Are you using it, or are you trying to implement it in your apps? Well, just to give you like the big picture, clean architecture is an approach or an idea proposed by Uncle Bob Martin, and it's basically a group of good practices that try to produce systems that are independent of frameworks, independent of UI, independent of data sources, and more testable. So this group of practices take into consideration this circle, which is called the dependency rule, which means that all the inner circles shouldn't know anything about the outer cycles. So the dependency should be, from outside to inside. This is, I mean, the number of circles here is not strict. You can have as many circles as you want, but the important part is this: the entities, your domain layer, yeah, the layer where you're solving your problems. So your business logic, So, with that being said, this is what I proposed. I wrote a series of articles related to clean architecture, and my proposal was to have like a three-layered architectural model where you would have a presentation level, you will have your domain level, and you will have your data layer. So I proposed to use observables from the data layer up to the domain layer, and then convert our presenters at the presentation level into subscribers. At the presentation level, I'm using a model view presenter approach, which you guys may be familiar with it because it's getting very popular now on Android. So I'm going to show you some code here. Um, we are going to start by the presentation layer. So the most important part here is this square here. What I'm saying is I have my presenter that manipulates some kind of view, and I'm just turning this into a subscriber. I will have at some point some observable performing some kind of job, and when that is ready, my presenter is gonna react to that data received, and it's gonna manipulate the view and update it. So that's how it works. Simple, right? Yes, again, so we said that our subscribers must override three methods, right? What happens when when our job is complete, we receive this signal. When we receive a new item on next is executed. These methods are named this way by convention. And when we receive an error, we do something with an error. As you can see here, when our job is finished, we are just hiding some loading view that we have in our UI. Then if we receive an error, we show an error, and then we show like a retry view. And then when we receive our data, we just update our view by displaying that bunch of data. Again, let's jump into the domain layer. This is where our problems are solved in theory, where we should solve our problems, our domain logic. That's not always true, but yeah. Let's stick to it. So here, at a presentation level, I have what I call a use case, which is something that you need to get done in order to do something within your app, or the user needs to do something within your app. So for example, in this case, this is a parent class which I call a use case, and the important part is here. So a use case is gonna have an observable which is gonna perform some kind of job. So what is important is the subscribe on. I'm just saying, okay, so with this observable, I want to this guy to be executed in any thread available in my pool of threads, in my thread executor. And then I want the results to be received in some kind of another thread, which is this guy, and this is an Android main thread. So it's as easy as that. We're just grabbing an observable and just saying, all right, you are gonna perform this task on a separate thread, but when you get the result, just move them to another thread. In this case, since we need to manipulate the view, we need all the results to be in the Android main view. This is a real use case, which is I'm just, for some reason, I'm getting a list of users, and I'm just extend my use case. And as you can see here, I'm just calling a repository. At a data layer level, I'm using a repository pattern. You might be familiar with it. It's just a way to abstract from the different data sources. I'm just getting the data, and I don't know where that data is coming from. I don't care whether it's come from the disk, from memory, or from a cloud. I'm just saying, all right, you give me some data I need. So at a data layer, something to highlight here is that I have an observable, right? And this observable is gonna get some user detail from a user ID. So I'm just calling my API at a data layer, which is great. And then this is what I mentioned before. I'm just producing a side effect here when I receive my user, and I'm caching it. So it's as easy as that. And this is, of course, is the verbosity I was talking about before. When we create an action, we need to do it this way. Action 1, which is not very friendly in terms of readability, but it's an action 1. And you can save some code if you're using lambdas here, but again, with the current IDEs, we have a lot of code folding options, so we can at some point see fold this and see like as a lambda fashion way. So what else? I know that there is a lot of code here, but yeah, it was just a way to like highlight some of the important things that I have been mentioning here. This is another thing that's more architectural approach that I decided to use for each layer in my clean architecture approach. I decided to use a different entity model or data model or whatever you want to call it, because I want to like decouple each layer, so that favors testability. So basically, here I'm mapping, I'm transforming my data model coming from the API to a data model for my domain layer. And this is the way how we create an observable. We said, and I like to repeat a lot so you guys keep the idea, that an observable performs some kind of task. And this is the way, for me, the best way to create an observable if you want to like be more flexible. There's some built-in methods that you can call in order to create an observable. For example, one is observable.just, and you pass in a list of elements that's gonna like generate push to the subscriber a list of elements. But here we have more flexibility, because when we use this method in order to create an observable, we receive the subscriber, and we specifically need to call the subscribers on next method ourselves, which is, of course, it involves some more code, but we gain the flexibility, so we can do whatever we want. We can trade, errors here and so forth. So the question is, once we know the foundation behind RxJava and we are excited to use it, or at least to play around it, how do we start with it? Because this is actually a recurring question, because many people say, yeah, I got my solution already with a lot of code, and then it's really hard to introduce RxJava. So I would definitely suggest that you should start by the data layer, because here is pretty safe that you should be already out of the Android main thread, so you don't have to deal with any asynchronous tasking. So this is the first step I would take. The second one, maybe at a view level, that someone here was commenting that you're is using RxJava at a view level. We don't use it at a view level. We didn't find any like solution to our problem. So I think there is some ideas to introduce it. So you can convert basically your click events or all your events into observables, right, and subscribe to them. There is our Rx Android bindings, right? That is a library for doing this. at a UI level. This is a C# example actually. And at a domain level, when you want to introduce RxJava and you have to deal with domain objects, keep in mind one thing, that this might be, the place where I start dealing with threading and stuff, so you can basically screw it up. uh, you can actually start, like, if you don't know how to use RxJava properly, you can start jumping between threads and stuff, applying schedulers on one observable on the other. So I would definitely suggest that if you can have someone or ask, someone experienced on RxJava, especially when you're dealing with this, that would be really nice. But there is another thing that you can do. The way we introduce our RxJava was just vertically. We just grab a new screen, a new feature, starting from scratch, and then from that screen we started using a completely different approach. This has pros and cons because it can introduce what we call a lava anti-pattern, because you start having different ways of doing the same thing. So if you have like 2 or 3 screens with different RxJava approaches, then when someone new joins the team or start working on the app, is what's the sample code I should look at, and then you start dealing with like different ways of accomplishing the same task. So keep that in mind as well. Some tips and tricks is that by default RxJava is synchronous. Yeah, that's pretty curious, because but yeah, it is like that. If you don't apply any scheduler, the observables are gonna execute their task in the current thread. Again, this is an important one. Has subscriptions leak memory, and yeah, read the official documentation. It's really nice, and there's like a huge community around RxJava. So I will definitely encourage you to start playing with it. Some references, of course, the official documentation. A colleague of mine wrote some articles about how we started with RxJava. There's another video as well. I'm gonna share the presentation so you guys have all the references in it. And there's like these 2 repos I created. If you guys are curious about all this code we have seen so far, go to this repo, and the issues section of it, there's like a lot of discussions. I like to have them there because people are like proposing new features, proposing another ways of doing other things, other ways of thinking, which is like very rich. And I think that's pretty much I've got so far. So and we have still some a couple of minutes for questions. Mm, so the question is if you're gonna use Rx bindings at a UI level, right? Yeah, we're still didn't decide that, but it's a matter of priorities, because we do know that could be cool, but we didn't see any added value to that so far. So I cannot answer that right now, because it's on our to-do list as many things, but there's no, like, I couldn't mention any con, any disadvantage of using that. All right, cool. Yeah. Mm-mm.
So maybe can you describe the debugging process? Let's say if you have like a big stream, how do you debug? Are you using debugger or just print to the logcat everything or cover everything with the tests, you know?
Yeah, well, that's actually a good question. Yeah, since there's this is a downside of RxJava as well. It's pretty hard to debug, and I guess everyone who has used it has already experienced the same thing. So basically, we started on site a project for handling, logs, on RxJava. I started a project which originally was called Gandalf, and then it turned into something called Frodo, which is yeah. Um, so it's basically a library, an Android library for debugging RxJava, and we are using that in our company. It's basically you will annotate an observable or a subscriber with just Rx subscriber annotation, and then you will see all the data on your logcat. In other ways, as you mentioned, is the debugger. But sometimes, if you have like a big stream and you wanna like have more data, it's way more complex. So we are using that for that. If you wanna know a little bit more, we can talk a little about later. Yes. No, the thing is like it's a project we started on site like some time ago, and then we open sourced it um, like a couple of months ago. So it was working pretty well for us, and we didn't need to rely on third party libraries. But you're using an Rx lifecycle or something like. Mm. All right, like I mean, you can create your transformer actually, or like you can use the do on next operator in order to log what's going on, right? That's what you mean. All right, let's talk offline. What is it? All right, yeah, yeah. Well, yeah, I see that as like very, I don't know, like registering global errors. I will try to avoid them first. Yeah, yeah, yeah. Sure, sure. I mean, yeah, it's a valid practice if you want to log. It's fine. Yep,
Yeah, I have a question on a related
yep.
topic, I guess. In our code base, we have used RxJava quite a lot, and unfortunately, it's also very easy to forget on error handling, for example. And especially if you mix that with schedulers, then you get these stack traces which end nowhere. So does Gandalf or Frodo solve that, or
All right.
any guidance on that? Because I was also trying to build something to figure out where the subscription happened, but then magic happens in RxJava itself, which makes either causing a lot of memory leaks or just random unsubscriptions or whatever side effects. So I find it very hard to solve that problem, especially from. I mean, errors happen, of course. So if you see some crashing crash releases, there's no way how you can
Ye-
resolve that currently.
Yeah, I completely understand that because I think some time ago we were in the same boat, and it's pretty hard to when there's like this magic behind, and this is actually what makes RxJava pretty cool as well, right? And so the thing is, yeah, maybe it's a good candidate for a new feature on Frodo or Gandalf to just keep track of the subscriptions and some internal stuff. And yeah, 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 it's true, it's true. But yeah, we can talk about a little about later, because I do want some input on this, right? Any follow up questions? All right. Thanks for your attention and patience.
Thank you,
Thanks.
Fernando.